Here we are going to have a quick summary of the most important statistics subjects for learning machine learning concept and getting ready for interviews. Variables. Variables are divided in two categories: quantitative variables and categorical or qualitative variables. Quantitative variables are divided in two categories: discrete and continuous. The difference between discrete and continuous is the discrete one cannot be divided into smaller units, but continuous can be. So as you see in this example, number of students in a class is an example of discrete variables, and we cannot have half a student or 1.5 student. We have 1, 2, 3, and so on as students. But for the continuous, we can have like smaller units, so like 1.7 kilogram or 2.5 kilogram. The continuous one can be divided in two categories: interval and ratio. And like temperature is an example of interval, and ratio, like height and age, is an example of ratio. There, like, to differentiate these two, it can be a bit tricky, but we can say the interval has no true zero. And what I mean by that, we can have -1 centigrade or Fahrenheit, and we can have 0. We can have positive numbers, so it doesn't have a true zero. But ratio has a true zero, and we cannot have let's say negative height or age or something like that. Categorical and qualitative variables are divided in three categories: binary, which as the name suggests can be very easy to distinguish. It can be 0, 1, spam or safe, and so on. And the other ones are nominal and ordinal. It's a bit tricky to distinguish these two as well. So what we can do is we can say the nominal is not sortable, but ordinal is sortable. So if you want to remember that the ordinal is sortable, the odd one here can be used for order, and it's going to be sortable. So this way you can remember. Example of nominal can be color, genres, like of the movie genres, which you cannot sort them, but grades and product ratings are sortable. So for quantitative variables, we can use a histogram to show them, and for categorical, we use bar plots. Probabilities. The independent and dependent events. An independent event is a series of events. The outcome of one event has no effect on the outcome of other events. An example of an independent event is like throwing a dice, and every single time that you throw a dice, you have an equal chance of getting 1 to 6. Like let's say you throw it once and you get 6. If you throw it again, you have an equal chance of getting 6, 1, 5, and any of the numbers. But for the dependent event, they are exact opposite of independent event, which means it's a series of events and in which the outcome of one event has an impact on the outcome of other event. One of the popular example of dependent event is a marble bag. So let's say we have a bag like with 5 marbles, 2 blue and 3 red. If we draw 1 marble from this bag, and let's say it's blue, so we are not going to have an equal chance of getting blue and red like before, because right now instead of 5 marbles, 2 blue and 3 red, we have 4 marbles, 3 red and 1 blue. So as you see, the outcome of one event has impact on the outcome of other events, and this is where the conditional probability comes into place. So the way that we read this is like a probability of A given B has happened, and this is how we calculate it. Now let's talk about intersection, union, and complement. Intersection is, as this picture suggests, is when probability A and B, they have overlap. For dependent and independent event, we have a different formula to calculate intersection. This is how we show it, the intersection. And the other one is union, and this is the symbol that we use to show it, and it says probability A plus probability B, and it says minus probability, the intersection of these two. The reason that because they have overlap, this area is calculated twice, and we need to deduct that from probability A and B, so we do not consider that two times. And the complement rule is like when we get all the area, all the probability except like A here. So probability, like complement rule says probability of A bar is equal to 1 minus probability A. Bayes theorem is something that we might see a lot in machine learning models. And the way it works is the formula that you see, probability A given B has happened. And two other things that we need to know is permutation and combination and their difference. The difference between them, in permutation order matters, but for combination order does not matter. What I mean by that is, like, let's say we have two letters A and B. If we want to get the permutation of A and B, we can get AB, we can get BA, and if the repetition is allowed, we can get AA and BB. But for the combination, the order does not matter. So AB and BA, they are both the same. So you can also see, like, when we have repetition and when we have no repetition. So when for permutation we have repetition, we can have AB, BA, AA, BB. And when no repetition is not allowed, we can have only AB and BA. The same thing for the combination. For the combination, when repetition is allowed, we have AA, BB, and BA. Here could be AB as well, because these two are the same for the combination. And when the repetition is not allowed, we can get AB. These are the formulas that we can count the number of permutation or combination that we can get based on the number of letters that we have and the number of spots that we have for the permutation or combination. Now let's talk about population, sample, and outlier. As you can see in this picture, population is the entire data set that we want to draw a conclusion about. Like all the schools students from all over the United States. But as you can imagine, it's going to be very hard to run tests over the whole population. It's going to be very costly. So what we can do, we can have a smaller set which is randomly drawn from the population, and it's a fair drawn. So the sample that we have, it shouldn't be biased. So as you see here, we have like blue, black, like gray, orange, and we have them all in the sample. So there are different methods that we can there are different sampling methods, probability and non-probability, and each of them are divided into subcategories. Like we get 700 volunteer students from all over the United States instead of all the students of the United States. So this is the sample that we run test from. This picture has been taken from OmniConvert. Throughout these slides, you will see logo of different websites and their links, which means I have taken this information from those sources. And they are very good website that you can go through them for in-depth understanding of this concept if you're not familiar with them. Now let's talk about outlier, noise, and anomalies. So outliers or noise are data points that they are from abnormal distance from the other observation. As you see here, this is an outlier because this observation, this data point is from abnormal at the abnormal distance from the other observation, and they can skew the model. And now let's talk about variate, univariate, bivariate, and multivariate. When we have one variable, we say univariate. When we have two variables, we have a bivariate. And when we have more than two variables, we say multivariate. So statistical measures. So we need to measure like statistically or data set, the data points that we have. And there are different measures like central tendency, central dispersion, and association. Central tendency has different methods like mean, median, mode. Central dispersion has range, variance, standard deviation, and IQR. and association has covariance and correlation. These are the most popular ones that we talk about here. So let's talk about them in more detail. So central tendency measures. Let's talk about mean. Mean is shown using mu or x bar. Mu is when we have the mean of the population, and x bar is the mean of the sample. The way that we calculate mean is we get the total number. Let's say this is the data point that we have. We get the total numbers and we divide them to the number of data points that we have. The thing about mean is good for numerical data, and it's very sensitive to outliers. So what we can do, we can use median when we have outliers and when our model is not asymmetric distribution. When we have asymmetric distribution, so median is a better central tendency. What I mean by that, let's say something like this: when the distribution is skewed to the left or to the right, and it's not a normal normal distribution, standard distribution, something like this that you see. So median is good when we have asymmetric distribution. The way that we calculate it, we sort the numbers and find the middle number. So as you see here, we sort the numbers for this data set and find the middle number. But because we have even number of data points, we get the two middle numbers divided by 2, and this is the median that we got. We have also mod, which is going to return the most common occurring number. As you see in these data points, we have 3 and 3 twice. So this is the most common occurring number, and we are going to return it as a mod. And mod is good for categorical data. Now let's talk about central dispersion measures. So range. Range is something, the difference between the smallest and largest number. So the largest number here that we have 7 and the smallest 2. So the difference between these two is the range. Variance is something that shows how spread out the data points are around the mean. So the way that we calculate for population is this formula, and for samples is this formula. The only difference is this is going to be n-1, which is n is the number of data points that we have, and this is going to be n. We get the minimum, we get the mean, and the way that we do it is like after calculating the mean, we get the distance of every single data point to the mean, and after getting that, we get the distance and we power that to 2, and then we divide it to the number of data points that we have, and this is the variance that we get. Now let's talk about standard deviation. The standard deviation shows how spread out the data is around the mean, and it's good for identifying outliers. So the reason is when we find data points that are more than one standard deviation from the mean, we can find those data points unusual. The way that we calculate the standard deviation is we get the variance and we get the square root of variance. So something that you need to know is when we have normal distribution, something like this, a mean is here. One standard deviation to the right and to the left is the red area that you see here, and it's equal to 68.27% of these under the curve, right? And these are rules. These are not something that we calculate every time. So it's going to be 68, 95, 99.7 rule that I got it from Simply Psychology, this picture. So, and if we go to a standard deviation from the mean, this is the area that we get. It's going to be the whole thing, right, from here to here, which is equal to 95.45%. And if we go 3 standard deviation from the mean, is this area under the curve, and is equal to 99.73%. Now let's talk about standard error. Population standard deviation estimate how spread out the individual value are from the population mean, right? As you see in this picture. So the standard deviation shows how spread out the data every individual value is from the population mean. The standard error, what it does is estimates the accuracy of a sample and how a sample mean is likely to be, how far a sample mean is likely to be from the population mean. So the distance between sample mean and population mean. So what we can do, we can get the mean, and based on the standard error plus minus is going to be the difference between sample mean and population mean. The way that we calculate it, we get the population standard deviation divided by number of the data points that we have in the sample. And another central dispersion measure is quartile. Quartile is like, in quartile, the good thing about quartile is all the data points are considered for the quartile, and the way that we get interquartile range, which is something that we will use a lot for machine learning and statistics, is we are going to get the data points that we have. We are going to sort them ascendingly. Then we are going to find the median, which is going to be here for this case. And then we are going to find the median of these two sets, which is going to be this area. And this median is called Q2. This median is called Q1 or lower, and this median is called Q3 or upper. As you can see in this picture, it's going to be easier to understand. The data points is 15, and the last data point after sorting is going to be 95. So the difference between two is going to be the range that we just talked about here, right? So the difference between the largest and biggest one. And what we are going to do, as you see, we get the median here, and then we get the median of the left side, and then we get the median of the right side. This is called Q1, this is called Q2, and this is called Q3. And the difference between Q3 and Q1 is called IQR, or interquartile range, right? And these lines are called whiskers. These lines are called whiskers. And what we can do with this IQR, it's a common practice is to set a fence that is 1.5 IQR from Q3 and 1.5 from Q1. This, and any point after that can be considered as outlier. As you see, Q1 minus 1.1 IQR and Q3 1.1 IQR. As you see, any point after this is going to be outlier. And the other thing that we need to know, we are going to we need to know what percentile is. Percentile is 99 values that split the sample into 100 equal size subsamples. Now let's talk about association. If we have two variables and we want to know the relationship between these two variables, we use association. Association for population is the formula, covariance is this, and covariance for sample is this formula. If two variables in two different dimensions, if they have if the covariance is positive, it means they are both both are like going toward a positive value, and it shows the two variables move towards the same direction. And if it is negative, it means as you see here, it is going towards a negative direction, inverse direction, and they have and the covariance is negative, which shows two variables move in inverse direction. And the covariance, if it is closer to zero, it means there is no relationship between them. And when we get further from 0, it indicates a stronger relationship. Now let's talk about Pearson correlation coefficient, or Pearson R. This measurement measures the strength and direction of a linear relationship between two variables. This is how we calculate it. And when it gets to -1, it means we have a strong negative relationship. If it gets close to 1, it means we have a strong positive relationship. And as it gets closer to 0, it means there is no correlation between them. Now let's talk about distribution. So I got this picture. It's not the highest quality picture, but I got it from here. You can go on this website and see it. And the thing it does, it says if the data is discrete or continuous, we can decide on the type of distribution that we are going to get. If it is discrete or qualitative, then what we get is it can be binomial, it can be uniform discrete, it can be geometric, it can be negative binomial, and these are the distribution that we are going to get. And it depends on if it is asymmetric or it's symmetric. And also for continuous variable, we can get uniform, we can get normal distribution, logistic, exponential, and so on. And these two tables show the distribution for discrete variables, and this is for continuous variables. And you see the formula, how we can calculate the probability, the variance, the mean, and you don't need to know them like the formulas, but it helps to better understand these different distributions. And the sum of all the individual probability for the discrete one is going to be equal to 1, and the area under the curve for the continuous one is going to be equal to 1. And I think the most common distribution that we would see while we are doing the machine learning or statistics is going to be normal distribution or standard normal distribution, which is called Gaussian distribution as well. And it's a symmetric distribution, and mean, median, and mode, they are all equal for these distributions. And the total area, as I mentioned under the curve, is going to be 1. And one thing about the standard normal distribution is the mean is going to be equal to 0, and a standard deviation should be 1. And this is the formula it has, which we will see it in the part 2 of statistics. Thank you.